So, without further ado, we're gonna introduce Solar Steve Hannon with A&R Solar. I'm gonna read a blurb here and then Steve's gonna do a better job of introducing himself. Civil environmental engineer with 20 years experience, renewable energy assessment, energy guy, efficiency audits in the Northwest, and he's been with A&R Solar for 6 years. He's helped over 400 people add solar and battery backup to their homes. So please give one. Solar Steve.
Thanks for having me for the guild. John, thanks for answering my email. I saw that there was a battery discussion. They were looking for speakers, so I said, why not? I'll reach out. So thanks, John. I work for A&R Solar. That's Andy and Reeves, the A and the R of A&R Solar. We've been around for 18 years. Over 5,000 projects for solar, over 500 battery projects to the tune of about 1,000 batteries. We do both Oregon and Washington, so Eugene people, we do Oregon too, so we do the entirety of both states. So yeah, let's get started. This is a new construction project that has solar and batteries, nice covered roof. So what are we gonna cover today? Battery backup, what type of power outages do you get? How does it work? Different solar and battery backup examples, energy storage overview, vehicle to home charging, smart panels, and then we'll look at Q&A, and one of which is, I have a question for you. If you've heard, do batteries add home value to homes? Because if you had a generator, that can add home value, but have you heard if batteries add home value? So curious about that one. In the top right here, this is a Franklin battery system. 2 batteries here. You can see we're intercepting the service and it's going into the A gate here. So that is actually taking your power. It's not going to the meter anymore. It's actually going to your A gate now, which is the hub of energy. And then it's going to the batteries and your solar is coming in here. So this is a retrofit project. So what type of power outages do we get? We get storms in Washington. The most common power outages are windstorms in November, ice storms. Those are the ones people remember. The earthquake ones, we don't remember because we haven't had the big one yet, but the big one can happen at any time. If you have batteries, you could weather earthquake outages. The other outages we've seen recently are heat domes. Issaquah lost power. They had a substation lose power because it got so hot during the heat dome. It was 110 degrees out. Wildfires had happened in eastern Washington and take out a transmission line. Cold rain and snow, wind, ice, and then brownouts. That's something we'll see more in the future. We're getting a lot more electrification. There's a lot more electric cars getting on the grid. We're having more people go from gas powered homes to heat pumps. So we're adding a lot more heat, energy to the grid, plus data centers. I mean, we're talking millions of kilowatt hours getting added with data centers. What that's doing is we're not able to build more dams. So we're either importing that energy or we're gonna potentially have more brownouts like they have in California. So as a visual representation, ice storms, power poles going down, dams having lower amount of water, so we're importing energy, so that's making energy more costly. City Light had to go up an increase in energy price last year because they had to import energy, so our prices went up last year. Down here is wildfire, and then this is showing the Cascadia subduction zone for the big one, earthquakes. So how does it work? When the grid is on, you have solar panels, your battery's full, you're pushing energy back to the grid. If you're producing more energy than you're using, your net metering, or you're using that energy directly at your home every day. When the grid goes out, you have 2 scenarios. You're going to be islanding between your solar and your batteries. So you're running your house off the battery and recharging with solar simultaneously. At nighttime though, you're not going to be producing solar energy. You're going to solely be running off your battery power. The next day comes, you'll recharge your batteries with solar. Depending on your energy use and what you use at nighttime, you may run out of power at night, or you might still have the battery in the morning. So it really depends on what you're using, and we'll go over those loads a little later.
Hey, Steve,
Yeah,
I'd just like to clarify, when we were organizing this meeting, you guys folks said that you were fine with having questions as you go along. Is that still true?
yeah, questions as we go or at the end, I'm fine with either.
I have a quick question. Is that hub center, downstream of meter or before meter?
Before meter.
When does it go through the meter?
I'll show you one of the pictures. It's easier to show. So this is one of the batteries we have, which is the Powerwall. This is the Powerwall 2s. There's 3 of them. This is the Powerwall 3s. The chemistry has changed, so it's lithium iron phosphate. We'll talk a little bit more about that. And then these are charged from solar. So this is a solar system that's, you know, super clean on the roof. So having both solar and batteries, they work together in tandem for power outages. So other batteries that we have are Franklin. That's the one I showed earlier in the slide. These are Franklin batteries. There's pros and cons to both. I won't go into like really detailed analysis of Powerwalls versus Franklin. If you wanted to look at that, we can go in more detail at a later date. You know, this guy literally called me this week to ask about battery backup. And then this is I point this roof out for new construction. A lot of people do flat roofs, which you still can do solar on flat roofs, not just,
Why is the panels like a butterfly?
yeah. That's a good question. So, when they're flat, it is lower cost to do flat panels, but you get no warranty on for energy production. When they're tilted, you're getting more energy production and things like leaves can like flow off them more, but like if you have a flat panel and there's a leaf on it, like it's less likely to flow off of it. In this specific scenario, I did the V shape like this because if this was facing west instead, the shade of this handrail would shade these solar panels as the sun sets. So I did we usually do what's called a wave design, so you're doing east, west across the roof, if we're doing tilt. But I have half my clients do tilt, half of them do the wave design. Because you have an upfront cost of building the structure to actually be tilted. So is that cost savings worth the additional energy produced and getting a performance guarantee? So those are like the questions people
What's
have.
the minimum pitch they need?
Those are 10. 10 degrees.
10 degrees.
Yeah. Does that cover it?
You
Yep. So a lot of people kind of get this, graph, your loads are in the morning, breakfast and dinner, your solar production's in the middle of the day. With self-consumption, you could use your battery in these times of day and use your solar instead of using the grid. So that's what self-consumption is. Potentially could do that with time of use. We don't know exactly how time of use is gonna work with solar and batteries. Not every utility may or may not allow that, but if you can do time of use with the battery, you'd be able to use your battery during the high time of use times a day, which are those two. So this is a summer and winter battery performance. So this is, you know, high energy use in the summer. This is a heat pump house, all electric. So higher, like 70, 80 kilowatt hours in December. You're dropping down in the summer for lower kilowatt hours in the, 15 kilowatt hours. So net metering happens when the green goes above the red. Green is solar production. So in this case, May, but most typically April is when net metering starts. They're producing more energy than they're using and getting a credit for that energy that they're gonna use on this part of the graph. What's unique about this is how does it work in the winter? We look at worst case scenario, which is December on the solstice, shortest day of the year, least amount of solar production. You're getting about 10 kilowatt hours of production. These panels the battery here is 15 kilowatt hours. They're getting 10 recharge. So if they use the heat pump, they're only gonna get 5 hours of power with one battery and 1 hour of recharge. So 5 to 6 hours if they're using the heat pump. This house has a backup gas system. If they use the gas instead of the heat pump, they're actually gonna get 124 hours of power. So they're gonna turn off the heat pump when there's power outage, because then they'll get days of power. Because this blue line is the essential loads, what are they using during a backup situation, which is less. Because this also includes washer, dryer, dishwasher, oven. Everything that you use in a month, where this essential load is taking out a lot of those things, you're only gonna be running, lights, fridges, you can run whatever you want, the scenario will dictate what you're using, but their scenario is 13 kilowatt hours. Which is less than one battery, and they're gonna be recharging 10 kilowatt hours a day, so that's how you get days of power. Now, the interesting thing is, if you start looking at the shoulder, Susan, there's 20 kilowatt hours. 30 kilowatt hours, you're charging the battery twice over. When you're in this area, if there was a catastrophic earthquake that took down the grid here, you would have continuous power till October. Like a generator would cost thousands of dollars to use, fossil fuels to run that duration, where you're gonna be running for free. So this is the backup essential load, so I can put in my calculator that has a whole 10 more columns, but I didn't wanna give you all the details. We literally put in how many lights, how many fridges or freezers. In this case, this guy is using a furnace fan for his gas heating, not a heat pump, not an electric water heater. He has a gas water heater and controls, a microwave, router modem, and a TV for a few hours. So we can put anything we want in there to kind of calculate what your use would be in a backup power scenario. So common question people have is what is battery safety? So we're using the newest technology is lithium iron phosphate. It's a very much more stable chemical scenario than lithium ions. I talked to our Franklin rep, that's one of the two batteries. So part of this is from Franklin, part of this is from Powerwall to make this. I talked to them both. But Franklin literally has a dumpster that they put batteries in and they try to light them on fire. And they won't light with the lithium iron phosphate. So that's pretty cool.
So does that mean it has zero fire risk or just low fire risk?
They try to light them on fire and they can't get it to.
You're saying the Powerwall 3 has lithium iron and but the Powerwall 2 doesn't?
Correct.
And the current Franklin does as well?
Correct.
So what's the drawback though with the iron? Is
It's heavy.
it's heavier from the waste.
Yeah, these are 200-pound things. And then at A&R, we actually have an R&D team that analyzes solar panels, batteries. We actually put them through a feasibility study, but also install them on our employees' homes. I have a test site for one of our battery technologies. So we go through that level of rigor before we put it under. And then boring stuff, and I'm not gonna read everything, there's UL testing. That's a national lab testing different ways of these batteries, which is through OSHA. But the thing they do a projectile test, hitting it with a forklift. Is that gonna be a problem? They do the testing for thermal runaway. That's the problem of the past. They do it on the cell level, the unit level, and the module level. So each piece of the pie is getting tested for thermal runaway. And that's the problem of lithium ion.
What is thermal runaway?
They just keep getting hotter and hotter and hotter.
Oh,
The difference between the lithium iron phosphate, what's the advantages and disadvantages that from the old lithium batteries? Or
Safer.
just safer, but does it cost more? Does it have the same energy density,
Similar,
same cycle life?
similar energy density. The warranty is about the same. 10 or 15 years, depending on which battery you're talking about.
Cost is about the same.
Yeah, the good thing about the Powerwall is the inverter is in the battery, so you don't need a standalone inverter, but it's a string inverter, so it's kind of a dumb inverter instead of a smart inverter, so there's pros and cons. I won't go into that much detail because it gets kind of, it gets detailed of it, which way you're picking. But overall, it's big difference between Franklin and Powerwall is the inverter. That's like the biggest technological advancement between the two. But the Franklin can use any inverter, which is kind of cool too, because not every battery used to be able to use any. So that's why I say pros and cons of each. That's definitely one.
The LFP, you can charge those to 100%, right? Does that make a difference between that and the lithium ion only going up to 80,
Um,
the overall lifespan?
overall lifespan, like cycles, number of cycles, there is a warranty for their degradation, just like a solar panel has. They can be charged to 100%.
But I mean, just the newer LFPs, do they last longer than lithium ion?
They have the same warranty.
Oh, okay.
Do they last longer? We don't know yet, because the LFP haven't been around long enough to do that.
Okay.
Next, so all new construction type projects, this is either 320 or 400 amp service. It is a lot cheaper to back up one of these than both of these. So what I recommend to people is you make this one the primary load, everything that you want backed up, this is auxiliary things that you don't care is backed up, and you make one your primary backup or a partial home backup. Like, we're talking like $10,000 more to back up what?
Explain more why that is.
You need two of these for one, that's a few $1,000s. You're intercepting, your solar systems have to get split between both systems. And the downside is, they say this battery gets emptied, and this one has 100 or 60% left, say. This load can't use that battery, they're completely separate. So it's kind of like, it's better to like put all your batteries on one thing that everything you want can use, as opposed to not using it, because what if it's garden lights or things that aren't using a lot, like you don't need that. In your partial load. So I highly recommend just doing one.
So when this is wired up, do you do a lot of pre-wiring, like you're not gonna add it for right now? Like,
Solar,
yeah, for solar,
yeah,
like run it to where it's gonna be and then wait,
yeah, we do what's called a rough-in.
yeah.
So we could do a rough-in and so these are all retrofits. But rough-ins, we could be running conduit and then have junction boxes. Batteries, typically you're not doing rough-ins. Batteries, it's all like, we wanna. So the key to get involved with a general contractor is early, especially when you're planning out something like this with all this equipment. Is to get involved early so you can plan for space and how's the service gonna come in, because the service is now intercepted by the gateway, then it goes back into the meter. So the splitting of systems, just to go back to that, you would need two of these, and then you need a battery for each one. So you need double the space, and then you're doubling up the gateway, it gets complicated. And physically limiting the space. Another thing to think about with batteries, where they're going, these are non-operable windows. You can't have a battery within 3 feet of an operable window. You can have it within 3 feet of a garage window, because that doesn't count as an entry point into the home. So that's like one nuance, you could put a battery right next to a garage window, but a house window you need to be 3 feet from. You also, if you put them in a garage, you need a heat sensor, and you need 5/8 inch wallboard anywhere there's a living space adjacent to them. So like if there was a bedroom above the garage, but most new construction, that is standard.
And does that hold true for the new batteries that supposedly came for?
It's still a
Okay.
state rule.
Okay,
Yeah, it's international building code. So if I were building a new home, I would do a smart panel, because it's cheaper to do right away than try to retrofit it. But the smart panel, you can track exactly how much each breaker is using instantaneously. So you could say, have you ever been driving somewhere and go, oh, did I leave the oven on? You can look on your app and see if there's a load on your oven and flip the breaker on your phone, and it'll turn off the oven.
That's brilliant.
Or somebody could hack your system and turn it off. Just Dream 400 or something coming out, movie.
Yeah. Potentially. So this is how it works doing backup loads, so it's really cool with. It also tells you how much energy you're using and how much you save and turn it off, so you can see like down to the breaker what you're using. But it also tells you how much time you'll save on your battery in a power outage. So if you have, these are the must-have circuits, you know, fridge, lights, nice to have, will stay on until your battery drains 50% and then it turns off. And then non-essential loads is like your electric car, it will not be on if the battery goes out. But say in the summer, you're producing more energy than you're using, maybe you wanna charge your car because you have so much excess power, you could run your hot tub in the summer, you could run your battery on your car, you could run anything when you're producing more energy than you're using in summer. So having this gives you that full ability that as opposed to,
Are you able to provide a cost increase for the span? I mean,
how much more does it cost for
Yeah.
physical products? I don't know, $1,000 or $2,000. They're not a lot more. The limitation is actually how many breakers you have. It's like, I think they're coming out at 40 shortly. They're at 32, I believe. How am I doing on time?
For time?
Yeah. Okay,
Pretty good.
this is what the span panel looks like. That's the cover. The concept behind a smart panel is we've had an electric panel for 50, 60, 100 years. Like, it's an old technology. A guy left Tesla and said, you know what, we have not innovated the panel ever really. So let's do something about it. So that's how it kind of came about. It's like, let's make a panel that's like smart for your home. This is the monitoring system for Tesla. Every system's kind of similar monitoring, but shows you how much solar you have coming in. 4 is coming in, 3 to the house, 1 to the power wall. If you had a car, you could also be charging the car in a power outage, but you might not want to do that. Again, summer or winter time, could or couldn't. If the grid was on, you would see how the energy is coming or going to the grid, but this is showing a power outage scenario. You might be interested in specs, 2 feet by 43, you wanna have 4 inches in between, that's for venting. And then they can go up to 45 inches, but we try not to push it too high because they're so heavy. There's a dolly that helps lift it, but it's kind of janky. We expect more from Tesla, but it's
how much do they weigh?
200 pounds. It's really hard for 2 guys with like lifting straps or gals, to lift. Wow. And then this is just showing side by side, how the conduit's gotta run up into here. And they're actually, waterproof up to here. They can be submerged under water. This is the Franklin battery. It's 45 inches tall, so a little bit taller, and 29.5 inches, so a little wider. I didn't mention the depth. The Powerwall are about 7 inches deep. These are 11.4 inches, so they are a little more off the wall. So they do take up a little bit more space if like you're in a side yard and it's a little tight, or like worried about a car door opening and hitting it. It's really tight in the garage. So that's the difference in dimensions. I have to say, this is a really good design, like how they laid this out, the solar coming down. Having the gateway right here, intercepting the power all between the meter and the window, and having the battery right here, like that is super clean.
Did you explain what gateway is, people?
So the gateway is first like the brains in the system, it's also the literal hub of your energy, so it's where the power comes in, the power goes to the grid, where solar comes in, it's where an electric car would go through. It's all linked through the gateway, and then it's directing power, whether it's coming from your house, going to the grid, going to the battery to the house. It is what you need to have a battery. If you wanted to do like an electric vehicle without a home battery, which I don't recommend because car batteries aren't as robust as home batteries, you still need a gateway to be the brains. Which is a great segue, vehicle to home. So there are some definite pros and cons, and there's definite, like, there's room for improvement. The Franklin battery, there's a generator intake that you could plug a generator in and charge the battery and run your house. It's actually run the house, excess goes to the battery. That same generator intake, you could plug a car into and run your house. Now, the downside is it's 100% customized for each house. Like if you have a F-150 Lightning, you have to set it up for the Lightning. It doesn't necessarily work for, another car with a 240 outlet. It has to be customized to each car. It's not like any car can pull up and use this, which is unfortunate. And then that is where the technology would go, is maybe in 2 to 5 years, there's gonna be something more universal. But like the way of the world with universal car chargers happening or not happening, it's kind of, we're on the same path with this.
That's because of safety. All the companies they wanna make sure you don't get electrocuted when you plug it in, so they have different control, right?
There's a lot to it. We were just talking to the Franklin team about this, and it's safety, but it's also like with the electronics talking.
It's not standardized yet.
I mean, you just think it's just plug it in and play, right? Like you just plug it in and outlet, right?
That's,
But I heard it's because they have so much safety things on your plug, the electronics have to talk to make it work.
I mean, the gateway is helping this, but each car battery is a different battery. I mean, it's like we only work on 2 batteries. There's like 15 batteries we don't work on. And then there's other ones we haven't even looked at because they can't talk to solar.
So to say you have one electric vehicle, you get a different electric vehicle. Can that be reprogrammed remotely, or can a homeowner do that, or is that require a solar electrician, a battery electrician?
You'd have to call us back up for that.
Okay.
I think right now, like Franklin's down the right path, but it's not, we can make it work. One of my clients made it work for a Kia at his house, but it's like just for the Kia. And the Tesla is even more limited. The only car you can use for the Tesla battery recharge is the Cybertruck.
Do you know what the holdup with Tesla from allowing it on their other vehicles at least?
Well, I know the Cybertruck has a 240 outlet and most cars don't. So that's like the main, I would think. Tesla has weird rules. They don't always make sense to me. Like they will never allow generator charging for batteries. They don't think you should use fossil fuels. So you shouldn't have a generator, which works great in California, but it does not work in the Northwest as well. Because people, if you have a week-long outage, batteries can get you there if you have a gas house, being a heat pump house, it might get 24 hours. So if you have a generator intake, you can recharge the batteries while running your house. Once the batteries are full, turn off your generator, now you're back to battery. So Franklin's giving us that hybrid option that kind of covers all the scenarios.
But you have to reprogram it to use a generator when you're already using it with the car.
It would be, you could do both. Pros and cons of generators. This is my last slide, but the generators up front can be cheap, but there's a lot of fuel costs. A big one is fuel availability. Like gas lines are usually shut off during an earthquake. So if you have a natural gas generator, you don't necessarily have power if the gas is shut off. Or, gasoline's hard to come by during a power outage, catastrophe type thing. It's hard to get fuel clean up. There's maintenance. You need to run generators like every week to move the engine, move the fuel. So there's pros and cons, and they don't have like a 10 or 15-year warranty. Generators usually have like a 3 or 5 year. And a lot of people just don't like the noise. Like we have a lot of people that are on Bainbridge Island that are like, we want batteries because we don't want our generator.
Steve, can I interject?
Yeah.
We were replacing a diesel generator for one of our dams recently. It failed. We looked at an alternative from Cummins. In fact, it's a fuel cell generator. You just use cylinders of hydrogen instead. So much lower noise, you don't have the toxic output. The price tag was $1 million, so we ended up going with a diesel generator. There's a company in Canada called Ballard Power that is making, again, fuel cell generators that are much more applicable for housing. We do not have a contract with them. We have a contract with Cummins. So we weren't really able to find that as an alternative, but they're a very reasonable idea in comparison to a diesel generator.
Nice.
Yeah.
With that,
What longevity with Tesla batteries, are you like 20 years from now when the cells start dying, are you able to just replace the actual physical battery part and not have to replace the whole electronics? Or you basically have to just you have to get a brand new inverter for the new battery technology? And everything, right?
there's two generations of batteries we have. There's Powerwall 2 and the Powerwall 3. The Powerwall 2, you have separate solar inverters. So for that one, there's a battery inverter and then there's solar inverter. So the battery inverter will get replaced when you replace the batteries, but I mean, with certainty, I can't say what will happen in 10 years, like just like off the bat, but how I would envision it would happen is you would have to replace the batteries. The gateway might have to get replaced because that might be out of tech. And then you're re-intercepting the gateway with the new gateway with the old one gateway. That's what I would imagine. With the Powerwall 3, with the integrated inverter, your new technology probably has an integrated inverter, so it does get a little. Right.
Well, I mean, yeah. Seems like you should just be able to simply replace the battery and not have to replace the controller and all this other stuff.
We won't know until we get there.
May I read a question from
Yeah.
our online audience?
Yes,
At ANR, are you looking to Sig and Store or other solar plus B2H providers?
second store.
Yeah, it's on the screen too.
I'm sure we will look into it. Like I said, we have an R&D team, so we can look into that. But we have a whole R&D team that looks at any technology that's worth it.
Are you familiar with the General Motors, energy, the General Motors home system? Is that I just learned recently that they're offering something that works with their vehicles, and I was wondering, is that a proprietary system or something that you would use?
I don't know about the generator.
I've never, yeah, it's weird, it's GM.
Yeah.
And they have a system very similar.
I think
there.
it's proprietary, just like the library.
Oh, okay.
Was there another question up there?
No, just stay down. We'll do maybe more question per individual and then we'll jump into the next presentation. And then at the end, we can bring both presenters up and shoot up any roundtable questions. Also.
Yeah, I had a question from Eugene. This is Kathy. I wanted to say that I was part of the Y2K movement. Took a 10-week class at Lane Community College about how to prep for Y2K. And I've been involved in solar kind of casually for like 50 years. But I'm just kind of wondering, one thing you might want to put in your cons about the generator is that if you don't have it hooked up correctly, you can actually kill a lineman on the electrical lines. And so that's something a lot of people might just be amateurs thinking they can hook this generator up. But the other thing I remember is there was a generator that had come out that was supposed to be quiet, and this was years ago, that you put it under the ground somehow. So, and I'm just wondering, when are we going to have, how about biodiesel to run the generator? Because I went on a sailboat in Fern Ridge Lake on a Indian restaurant fuel. And a boat one time, a sailboat, the engine with, so I'm just saying that there's a lot of other alternatives we could figure out, I think, if we had some creativity.
The biodiesel and generators.
Yeah.
I mean, to be honest, I don't have a lot of experience with generators other than replacing them or knowing how to hook them up to batteries.
We've been using renewable diesel and biodiesel for decades at City Light. So renewable diesel is a drop-in replacement for any type of diesel that you're looking at. Biodiesel is a bit problematic because of the solvency issues. And so you can basically destroy all your gaskets and things like that, whether you're putting it into a vehicle or into a generator. But renewable diesel has, we think, pretty good environmental characteristics to it. And we've been using that for a while with great success, so.
Thank you so much.
Thanks.
Hey,
Your hand. Give me a second here, folks, for an introduction. And at the beginning, I meant to say we're in for some really great information tonight, and we're seeing that come to fruition. It's really much appreciated. I caught a lot of that. Some of it went, a lot of numbers, but it's fantastic information and some compelling things to think about, to ask more questions. Here's another fun fact before I introduce our next fabulous speaker. There's a comet in tonight's night sky. So I don't know how to tell you exactly when and where, but maybe we'll see the comet. That way, west. Gonna look west and see a comet in tonight's sky.
Still meteor shower going too. We're going through the debris from Halley's Comet, so the Orion meteor shower, we're tailing the tail end of that soon.
Fantastic. So do we have to go out remote to see it? Like 20 miles or so?
Dark is good.
Yeah,
we can go right on the grass rip right here.
try that.
That'd be okay.
Okay, that'd be cool.
Does that have anything to do with the wombats?
You know, they're closely related. If you look closely, you can see a wombat riding on that comet. Thanks for asking, Chris.
Yeah, you're welcome.
Okay, so if that's our presentation by Solar Steve, then obviously our next presentation is by Electric Larry. That's Larry Garcia. He's a senior environmental analyst for Seattle City Light, and he works on electrification and other cool stuff, including battery electric storage system for the ferries and also for the Miller Community Center. They have a micro system there, and I'm pretty sure he's gonna talk about that. And he looks at the environmental and safety side of things. So thanks for chiming in on that last comment too. And he says, they have electricians to figure out what kind of battery do we actually need there, stuff like that. That's not what he does exactly. But he also looks at the sustainability, such as how efficient is the system actually. So with that, please welcome Larry.
Thank you. All right. Thank you all. Yeah, again, Larry Garcia, senior environmental analyst. I do weird things, but not electrical work primarily. I'm involved with our team of electricians and electrical engineers and evaluating what we're trying to put into our operations. So whether that's an emergency generator going in and the type of fuel that we're running off it, or the products we use to maintain our fleet of vessels, take your pick. I get involved in the material side of things. So when we're looking at the ferries wanting to electrify, we wanted to have a backup battery system. And so we hired some third-party consulting engineers. I was in it from a chemical performance perspective, from sustainability perspective, a fire code perspective. That's what our crews use me for. So when we talk about, really we're looking at alternatives for storing energy. And batteries, for some reason, seem to be what we turn to, but there are a lot of different ways to store energy, including ways to store energy to actually get electricity back out. So it doesn't just have to be a chemical battery. Thermal sand batteries are incredibly impressive right now. The problem is they're huge. But there's some installations in Sweden where you're talking about maybe a 50-foot storage tank filled with sand. You're using electricity to generate heat. The heat is stored there. You have tremendous amount of capability to draw that heat out and generate electricity from that. It's incredibly impressive. I expect to see this being used tremendously. Now, comparably, it's not really for electricity, but do any of y'all use phase change materials in your construction?
Would like to.
Like to. They're available quite a bit. I'll mention that. I got a little slide on that.
Wait, I do use water. Isn't that a fixture?
Well, like ceiling tiles,
Or a fixture?
where you actually have phase change materials built in, you do use those.
No.
No.
The bioengineering at UW used it extensively
Okay,
with really
great.
good results. During
Yeah.
the first summer, the students came in and said, your air conditioning works so well. They say,
Mhm.
no air conditioning,
Right.
all phase change, all wax base.
Yep, paraffins are one of the key ones. Low toxicity. There are some other materials that are used. So it's again just another way of absorbing energy And the nice thing about the phase change materials is they release the energy when it cools down, so you warm the space up, and when it's too hot, you pick them by temperature. So you go in, you get a ceiling tile, we want 72 degrees, so we get a ceiling tile for 72 degrees, or for 68 degrees, or whatever temperature you want, and that's where you get this huge energy absorption as something goes from solid to liquid. It's really cool. Mechanical, gravity. Yeah, I got some slides, but Yakima Power is going with a giant mechanical battery system. It's a large weight on rails. And when there's excess hydroelectricity, they take that giant weight and they move it up a hill. They're using an old landfill site, which is a great place to do it. There are no relics that they're disturbing. We're not tearing down some kind of forest that's ancient. It's a great spot. Compressed and liquefied air. Now, gravity, in theory, we might be able to use for housing at some point in time. Certainly not, multi-ton bricks for a house, but think dumbwaiter type ideas, where a way to actually bring a weight up in a small area and have that potential energy then just drop to generate electricity again is at least theoretical.
Or water.
Or water. From a housing perspective, I had concerns about water, but certainly for hydroelectricity, they're putting in, looks like in Goldendale, a nice hydro storage operation where you pump water, Banks Lake out in eastern Washington, where you have a lot of water that gets pumped up to get Banks Lake, and when they need the water, they send it back through Grand Coulee. And then when they have excess power, they take water and pump it up to Banks Lake, and then when they need the energy, they pump it back down through the turbines. So water is excellent. And then finally, chemical. So I seem to have copied sand again. There are a couple major players. There are flow batteries. I have very little hope for flow batteries ever getting to a point where we could use them in housing. We were looking at a flow battery for the ferries. There's a nice iron flow battery. You take iron, you rust it, and then you turn it back into iron again, and then you turn it back into rust again. If you have a spill run through your life, you spill rust. I mean, incredibly low toxicity. For the type of energy we were looking at putting in one tank of electrolyte and one negalite and one posilite. They would both be about 50 feet tall and rather large diameter tanks to generate the type of power that we were looking at. They're also, one other big problem with them is about 70% efficient. So we hear weird discussions about batteries as far as a source of power. Batteries are a cost. All right, whatever energy goes into a battery, not all of it comes out. So if I'm getting solar, that's great. I'm getting free electricity coming in, and if it's a lithium ion battery, I'm getting 80 to 90% back out. If it's an iron flow battery, I'm getting maybe 70% of that energy back out. If we're connecting to the grid and we're getting, we're paying for 100 kilowatts, we're getting 70 back. That's a fairly significant loss from whatever you're supplying.
Aren't they also using flywheels?
Yes,
Huge.
yes,
I thought that's one they're actually using.
that is one they're actually using. These are all actually being used. So every one of these, the flywheels, a lot of moving parts. And again, from a smaller operation, like trying to design this for a house or a small commercial building, it's more for a large operation is what we're finding. Oh, right, I have it in my hand. So, let's see. I'm clearly pointing it the wrong way.
Oh, that might be a tech thing.
Clearly I'm hitting the wrong button.
Compressed and liquefied gas.
Yeah.
What about that?
So what you're doing is taking excess energy and you are compressing a number of different types of material to be used. Primarily things that aren't going to burn. Nobody wants to do hydrogen, but you compress it and then you just you open a valve and the pressure is released and you turn, could be some kind of a flywheel, some kind of a turbine, and you generate electricity.
Okay.
So you do lose some energy that way. You also have a compressed gas system. Some of the batteries, one of the more impressive ones, uses compressed gas cylinders, but it's actually a chemical battery inside of those cylinders. This is the one that has impressed me the most, quite honestly.
Yeah, with your thermal sand battery, how do you extract or how do you generate electricity from hot sand?
So it's from the heat itself. So it's very similar to almost any thermal generation plant that we have. Yeah, whether it's coal or nuclear, it's just a different way to generate heat, and you're just getting the heat back out again. with some kind of a heat exchanger and turning a turbine in that pattern. Yeah, it's very comparatively low tech. See if it work. Hey. So for the microgrid that we put into the Miller Community Center back in 2022, have a rooftop solar system. Got the size, got a 70 kilowatt load, and they got 200 kilowatt, 800 kilowatt hour system put in there. And we ended up with a couple of NEC batteries for a backup system, and LG now owns them. We'll talk about a couple of different companies here. LG is bigger than all the other companies that we'll talk about combined. So, you know, ESS is the big gorilla in the room for iron batteries, whether it's iron flow or iron air. They're the 800-pound gorilla, and LG is a blue whale. All right, so there's no comparison. The reason we went with lithium ion, we looked at other technologies. We looked at Lockheed, for example. Lockheed has some organic batteries that are pretty impressive. They don't have a flammability issue. They have a lifespan that's actually really good. One of the concerns we have about the lithium ion batteries we've all looked at, the estimate is that about a 10-year lifespan is what we could expect out of them when you start looking at cycling and things along that line. I was pretty impressed by 15 years from Franklin, quite frankly. That's very new and very impressive. What we found for a lot of the alternative chemistries was a 20 to 30-year lifespan potentially, which for a $40 or $50 million investment, that's a big difference for us. And it's one of the reasons we're looking at the other technologies pretty seriously. At the time, we couldn't find anything for the small footprint we had here that would be able to work for us. That's no longer the case. So for batteries, so you've got a bunch of different players. You got lithium ion, vanadium flow, iron air, aluminum flow. There are nickel zinc batteries. You've got bromine batteries. Let's just kill them right now. We looked at the bromine batteries and wrote them all off because the toxicity issues with the bromine scared us to death. You know, the concept of let's get bromine and put it on the waterfront of Seattle. It's like, no, we're done. All right. Vanadium flow is another one. Snowpud, put in a large vanadium flow battery. The electrolyte has a pH of 0, which I always thought was theoretical. All right. We talk about secondary containment to keep oil out of water, things like that. For vanadium flow, they had tertiary containment for the electrolyte. It was so incredibly hazardous. And I don't know a single company that put a vanadium flow battery in that still hasn't worked. So there are a number of companies making vanadium flow batteries. I don't see a bright horizon for them, unfortunately. Zinc batteries are really interesting. They're probably not here yet. Sodium batteries are here and available now. Nickel hydrogen is here and available now. They're really looking at housing for these too. So we'll take a look at these. The considerations we have are variations in efficiency. So again, you can go from 70% of the energy input being returned to you to about 90%. So if you start looking at where you're getting your energy from solar, great. If it's hydro, you get excess power in the evenings. We have run-of-the-river hydroelectric plants where you have to send water through because the dam will fail if you don't send water through. And so you can either bypass the turbines or run the turbines and use that energy to do something, make hydrogen or charge a battery. They're great options. In the springtime, half the trouble we have out here is we get big winds and big water flows at the same time. So we have huge amounts of electric generation from wind turbines and huge amounts from flow from water. And we end up decoupling the wind turbines because there's no place for the electricity to go. Right? I looked at your graph on energy demand in the wintertime versus the summertime. And it's very different depending on where you happen to be. That's great for our area here. And for City Light, our concern is power generation in the wintertime. So we don't tend to look at solar too much for our sources because it's not the best for the time when we actually need the power ourselves. So we are looking to other sources primarily. California,
A real quick question, that scenario that you mentioned where hydro is at peak output and solar is in Eastern Washington, I heard that it was a grid problem, that the grid couldn't handle capacity and that we need to make an investment to upgrade it, or is that not true?
That's very true. So if you couldn't hear on outside, the question was whether the grid needed to be upgraded. we had huge issues being able to transmit enough power. That huge storm that knocked out power in Texas. Half the trouble is Texas has its own grid.
Right.
And there are very few interconnections with the western grid or the eastern grid. We had power that we could send them, but the interties are so small that they couldn't get enough power through. And their gas plants all went down, they froze, and so they lost gas capacity everywhere. Nuclear, they lost a nuclear plant. I have yet to hear any explanation on how they lost a nuclear plant in the cold, which just makes no sense to me. Wind did pretty well. Solar did pretty well, but the grid just couldn't handle the loss of gas and people froze to death. So toxicity is one of the other big issues. Bromine, again, we just wrote bromine off as being incredibly scary for toxicity. Corrosivity, we wrote vanadium off because of that. Flammability, even LFP, which is far safer than the earlier versions of lithium ion. Have you used any lithium titanate yet? Have you seen that coming through?
Yep.
There's a tendency for failure. There are dozens of different types of lithium ion chemistries, all right? Lithium titanate is pretty impressive. One of the ways lithium fails is with this dendrite formation in the battery itself. And lithium titanate appears to be very resistant to the formation of those dendrites. But over time, you start getting this failure that can actually increase the potential for a runaway reaction. There was a mall, I guess 4 years ago now in Beijing, and they have a battery system on the roof of the mall. Lithium iron phosphate, it caught fire and 2 firefighters died from that one. So it's very rare, unlike a lot of the other systems where, we see $50 million investments burning up in front of our eyes with toxic plumes coming off. The other concern we had with lithium is the use of perfluorinated compounds inside the batteries to separate the chambers. So when you have a failure, you do end up with hydrogen fluoride being generated in high concentrations and a lot of other toxic gases. So fire departments are very concerned. Even the small batteries, we had a truck coming in from Eastern Washington last year, recycling truck, the lithium batteries ignited in the back of the truck. It caught fire 7 times from East Side Fire and Rescue to the time it got to Kent. The truck no longer had back doors on it. The truck bulged out completely. It was a fascinating event. They had lots of fluorescent lamps for recycling with mercury inside of them, so there were mercury issues involved. It was lovely. So the fire department, Seattle and New York have been keeping track of this quite a bit because of mobility devices. They have e-bikes and e-scooters that are getting into trouble because they get immersed in water. I was really glad for the design for being able to get some of these batteries exposed to water. That's a huge concern for a lot of lithium ion batteries. Heat damage. There was a house in Snoqualmie that had a fire. They overcharged one of the lithium ion batteries for a snow machine. It burst into flame. East Side Fire and Rescue responded. They extinguished the fire. They pulled the snow machine out, or snowmobile, if you call it that, and they went home. And the following day, the snowmobile next to it had gotten some heat damage from the fire from the first one, and the lithium ion battery went into runaway and burst into flame. And that time, East Side Fire and Rescue lost the garage. It went up in flames. So the fire departments around the country, New York and Seattle in particular, Seattle reported 35 fires involving lithium batteries, last year. New York has recorded multiple fatalities from fires. One of our bucket trucks, one of our tools, it was a Makita drill, or a DeWalt, one of the two, burst into flame in the bucket with our workers in the bucket on an aerial bucket. We don't like that. We really are not happy with that. So we're looking at other alternatives, and those are some of the reasons. The other one's lifespan. When you're looking at, 30 years for an iron flow battery versus 10 years for a lithium, that's a big advantage. 90% efficiency for lithium versus 70% for iron flow. That's kind of a concern. Iron Air, Snowpud, has just contracted with Form Energy to put an iron air battery in. If you're living someplace and your power company is proposing, let's put in a lithium ion battery for a big BESS, even if it's lithium iron phosphate, I'd ask them if they're considering other options. Because there are plenty of options that go out and buy today that have a lot of advantages from lifespan, from safety. If there's a fire, not gonna be emitting horrible things.
No, but
Yeah,
just backing up on context, trying to understand, so obviously you have power generation sources, right? State and city owns some. So how significant is battery backup in terms of capturing that excess energy production? Would it like double the amount of power that you have access to in the system, or like how much focus is on this and how much focus is on more generation?
so California is probably the most impressive option we have currently for what the potential is here. During the day, they get a huge plug of solar energy, ridiculous amounts. And in fact, the price of energy goes down to zero in California. There's so much solar. It becomes a problem for your constant loads. Nuclear, you can't just turn a nuclear plant off, right? That's just not an option. So you have a base load that's there. And so you take all of your other intermittent loads, you turn them off because, or you sell them to someplace else, but you're selling them at a loss sometimes. But when the sun starts to go down, so around 10 o'clock in the morning to about 5 o'clock at night in California, and they're a lot farther south, so they get a lot more sunlight all through the year than we do in the wintertime, certainly. Pretty good in the summer, we're better in the summer. But about 5 or 6 o'clock, their batteries come on. And the batteries will run them from a state level for hours, right? If something goes wrong, they've got peaker plants that burn things like natural gas. But the batteries are really doing an impressive job. They're capturing the energy from the sun during the day. And in the morning, they actually pop back on with the batteries because demand just goes down so far, they don't even need the batteries too much at night.
So for how long has municipalities, whoever manage these systems, power systems, how long have they been using battery technology?
This is new.
Like super new.
This is really new. Yeah, they've been building a bunch down in California. It's quite impressive. We have nothing like that here. Snowplow again is trying this. They're probably farther ahead than most others. Yakima Power again is putting in their gravity system. So everybody's looking at it, and primarily if you have a run-of-the-river system. So the Columbia system, we have one big run-of-the-river dam out in eastern Washington for City Light. We have one storage reservoir for the Skagit River. The Sauk River is run-of-the-river, so all of our everything below that is just run-of-the-river. But if you have any inputs that go through a dam and you don't have control over it with another dam, water goes through there. If you don't capture the energy, it's just lost.
This is significant, like, it really changed the stability of the grid.
We've had such dry weather recently that we've had significantly lower flows, both in the Columbia system and in the Skagit system. That's why they've been getting tons of rain in California. We haven't been getting it very much up here, and it's been sustained for a while. So it's really a system of what kind of climate do you have at the time?
It's which system does California use right now?
What do you mean?
Battery system. What are
Oh, they've got a lot of lithium ion batteries.
the, they're using lithium-ion.
The ones that burst into flame down in just south of the bay there, those are both lithium ion systems, both the ones that burst into flame there. And had the toxic emissions that were evacuating people downwind, those are both lithium ion batteries. They're at an old PG&E plant, they're run by different companies.
You
And
know,
you find,
there was a dog that just jumped up on a table in the news 3 days ago of a fireman, and it bit the battery. It started a fire, and the dog and the cat ran upstairs. Luckily, they had that, one of those forever chemicals on the carpet that prevented the fire from spreading on the carpet. But also the St. Vincent de Paul, the major collector of stuff to give people at Christmas, the RoboVac, somebody had donated a RoboVac. It caught the whole warehouse on fire a year ago. And there were actually 700 fires in the first 6 months of 2022 alone in New York City. So the council passed the thing. They were going to put $25 million worth of battery chargers around town. And then they figured out, well, it's dark at 5 o'clock at night and you're sitting out there how long with your scooter. So now they're going to start doing battery exchanges. Yeah.
Kathy, do you have a question for our presenter?
Yeah,
Or we
well,
can-
the question is, do you know about hemp batteries? Hemp batteries have been around for at least 7 years. And David Mitlin has been working on them. And hemp is a substitute for graphene. So I think we need to put the money in a less fire-prone battery.
Kathy, we got the presentations. This is presenter time. Thank you.
I am unfamiliar with hemp batteries. So I've been looking at installations that are ready for installation for us primarily. We've been looking at some other chemistries. Ran across one company recently that has a unicorn battery. I mean, just everything's wonderful, and you ask them about it, and it's all proprietary, which means they don't have anything. It's something they've been researching, and I can't buy it, I can't put it into play, nobody else has purchased it and put it into play. It's a unicorn battery, and I hope it'll work, but who knows? As far as the fires, FAA has reported hundreds of fires in airplanes from things like this. If your cell phone starts to bulge, and you can actually see between them and your laptop. There are hundreds of fires from phones and laptops on airplanes in passenger compartments.
Nice. So what are they doing about that?
So there are companies that make kits specifically for lithium ion batteries. There are basically vermiculite bags, and they have gloves. They're kind of like the old asbestos gloves, but they're vermiculite, so you can handle a phone when it's 800 to 1,000 degrees. You can pick up the gloves, you place it inside this vermiculite packet, you close it, and you contact the pilot and say, we had a fire inside the cabin. What do you want to do? We have it inside the packet.
Yikes.
Wow.
And it's not gonna take the plane out. Yeah,
What about hydrogen then? You haven't really talked about that much, nickel?
oh, nickel hydrogen.
Yeah.
All right, so let's hit this first. Nickel hydrogen is by far the most impressive of the chemistries I've seen. Not even close, all right? For the waterfront, it won hands down. Smaller footprint, high energy efficiency, non-flammable, non-toxic, 30-year lifespan, 30,000 basically charge and discharge concepts for it. Really impressive. It's an old NASA technology that is in use in space all around us, satellites and things like that. There's only one company that makes them. They finally got the price down to a point where utilities can think about them. They're also looking at residential. The general concept is you put them in the wall because you don't need to do any maintenance on them for 30 years, which is fascinating.
Which company?
It's called Enter Venue. They're out of the Bay Area. You mentioned the UL standards, UL 9540, incredibly good test. They look at thermal runaway, gas composition, what sorts of toxins are released, heat releases, risk of ignition, risk of deflagration. Deflagration is a really rapid fire that looks like an explosion. If you can find it, it is an explosion. You'll get shrapnel, right? And we find these happening from batteries, unfortunately. So the unit installation level, and there are a bunch of others, but you know, they're all going back and pointing to UL 9540. So if you check NFPA 855, which is your battery electric storage standard from the National Fire Protection Association, they're pointing to UL. These are good systems. UL 9540 is the energy storage system itself. 9540A is the test. All right. We look for this at a minimum. So some other safety standards, NFPA 68 and 69. UL 1973 is a battery certification. 68 and 69 are looking at explosion protection and prevention design. 855 is specific for lithium ion. And there's a new one coming out from China, which is pretty cool. It's GB 38031 from 2020, and it's requiring a 5-minute warning of a runaway chain reaction for a battery, which is really impressive. They've got companies that are getting that technology available. China is, they're doing some amazing things. So nickel hydrogen, this is Enter Venue. I've got their website up there. Commercial and industrial, residential and development. It's really high efficiency. It's a small footprint, but you're talking about a couple 100 pounds. This is, you know, more like 9,000 pounds.
Oh, holy cow. Oh,
They're compressed gas cylinders. If you ever moved a compressed gas cylinder of nitrogen, you know, think of these as a 5-foot cylinder. They're big, no thermal runaway. It's not even a possibility. If something goes wrong, it vents water vapor. It can be a little bit hot, but it's not like a giant steam release.
How big is that box there?
Oh, it's, you know, somewhere along that line,
5 by 5.
something like that. Yeah, they're standard, you know, roughly standard size cylinders. They go horizontally, so it's one big unit.
But it's compressed gas, so if there was a projectile that hit it, it would explode, right?
It would not explode, thankfully. So you're exactly correct. I mean, it all depends on the pressure inside the bottle. They're not highly pressurized bottles. If you did get a puncture in the side, you don't get an explosion at these pressures that's significant enough to move the mass that you've got there. If you have a heat problem, there are rupture discs, and you will get water vapor released when the rupture disc goes. But you're exactly right. The biggest failure mode would be something actually projectile kind of hitting. Which is,
This is a hydrogen fuel cell.
no, not by a long shot.
Oh.
No, it's a battery. It is a battery. The nickel is actually impregnated on the inside of the cylinder, so it's not mobile at all. So it's closer to nickel metal hydride battery. That's the closest comparison I can make. And the closest I can understand to what they're doing from what they're able to tell me. But it looks like an old NIMH to me in almost every other way, except that it's a compressed gas cylinder, which is really weird. But it had the smallest footprint we could look at. It had the longest reliability.
That's what's powering our satellites.
Not all of them. There are sodium batteries that are being used in space right now too, that are pretty impressive. And some of the companies I've looked at recently are looking really at automotive and space and airplanes. And those are mostly the sodium battery companies, but a few of them are looking at household too.
How much they cost? Well,
So the nickel hydrogens, they were definitely in our price range for powering the ferry fleet. So we're actually looking at that as a cheaper option to the lithium ion batteries we're looking at. And the vanadium flows, they were all cheaper. There was a whole lot less to do from a safety perspective for them. The iron flow was comparable pricing too, so there was no real big difference, but we were talking millions and millions of dollars for a large installation to, plug in the Wenatchee when it shows up in the dock, So a couple of companies that impressed me. Alstom is interesting. You're looking at about a 20-year service life on a sodium battery. They have residential options available right now for the sodium batteries. There's no fire hazard to them. You're looking at Oregon, for example, the electrolyte is a solid electrolyte. This is one we're actually importing currently to take the place of some others. So we don't have a liquid. If I puncture it, it's aluminum. It's beta aluminum as a solid block inside, and the materials are flowing through that. It's really a fascinating concept. So they're available for home and commercial also. There are a bunch of others that are in this realm. Aqua Battery, Peak Energy. Peak Energy doesn't care about small operations such as houses and small commercial. They are looking at big industrial utilities, and there are actually some installations of the sodium batteries they've got. Celium is pretty interesting. They're looking at the 18650, which is the standard cell that you find inside of your Tesla battery or your riding lawnmower battery. The 18650 is a little bit bigger than AA battery. It's 18 millimeters across and 650 millimeters top to bottom. And you just take them and pack them together, and you get yourself a lithium ion battery. You can get nickel metal hydride 18650s, and you can get sodium batteries that are 18650s. So any use for an 18650, whether it's an e-scooter, whether it's their marquee for e-scooters, for power tools, for solar, for home energy storage, Celium is trying to get into all those realms right now. This is the one that's available. And then CATL, again, over in China, they're looking at a 15-minute fast charge for a car to get to 80% charge. Wow. Yeah. Wow. Yeah. This is the future right here. What we're looking at is sodium. I'm incredibly impressed with Enervenue. They floored me. This, we're actually trying to put in, replacing some of our lead acid batteries with some chlorine batteries. I just talked to our crews today to try to run that through, and we're finding no issues. The fire codes, the international fire codes, the one we have to deal with. They have a separate listing for sodium metal batteries. So you got lithium ion listed, you got sodium metal, they got vanadium flow batteries, they just got flow batteries in general. And where the rules kick in as far as how big the battery is. And these are fairly easy. So iron air and iron flow. I don't think there's much hope. Again, they're really impressive, far lower cost than lithium ion in both cases. You're using iron. I mean, it's really common, it's really cheap. They aren't as efficient, but they're non-toxic, they're non-flammable. They've got a really long lifespan. You're talking about 25 years to 30 years life before you have to change anything out. Fairly low key. Stable capacity, there's no cycling limit on them. Again, this is just air. This one's a giant flow with 2 tanks of liquid electrolytes. And then there are other flow batteries. So Lockheed, they've been having some cyanide issues with the Lockheed batteries, which has really soured a lot of people on it for good reason. Again, looking back at the toxicity items, a Toro is another one. It's a metal chelate, really high efficiency, about 80%, so comparable to lithium ions in general. Non-flammable, non-corrosive, neutral, non-toxic, but they're not telling us any details about it, which is one of those odd ones. Vanadium, the pH is just astoundingly low. And again, I don't know of any successful operations that are still running from the installations that have been out there. Aluminum flow is really new. They're focusing on air, space, and large industrial operations currently. Brand new type of flow battery. So I know very little about it. Unfortunately, it's intriguing to say the least, and they're not paying attention really even to utilities. And usually there's a reason why they'll choose certain uses instead of others. I'm keeping an eye on it. And then another one that's really pretty intriguing is solid oxide fuel cells. Noon Energy is a big player in this one. It's got a higher energy density than lithium ion, which we weren't sure was possible. You know, they've been having some, sodium is not as high an energy density. It's pretty high. It's not as high a density. This is even higher. It's got a smaller footprint. It's, again, pretty new. So Noon, again, is the biggest player in this one. A lot of these are coming out of ARPA-E. So it's the federal government's research and Department of Energy for new high-tech research in batteries and other sorts of energy systems. And again, just really pretty fascinating. For gravity.
Sorry, the last one is that it's powered by hydrogen, or what's the fuel?
So, not sure. Again, it's a battery, so we're not talking about a combustion per se. So it's not like a hydrogen combustion. It's likely that you have some kind of a hydrogen exchange, like in most batteries, but I'm not sure. Yeah. Metal oxides are used as sensors in most of your air monitoring equipment. So if you have an electrochemical sensor, it's usually some kind of metal oxide sensor inside of there. And it's an electrochemical reaction that's occurring. And this is probably similar to, you know, the 4-gas meter, a couple of the cells in a 4-gas meter for confined space entry. It's probably a similar technology, just one that's actually generating power for you. The sensors are generating power to give you a reading of something. Something's here, it's generating electricity when it's the sensor, and it gives us a reading off of that. And this is something on a scale with the intent to have it exposed to something to generate that power. Beyond that, I don't know the details. So gravity, very cool. Couple big companies, you know, Energy Vault, Areas North America, really high efficiency, you know, 90% efficiency in using energy to just lift something really heavy, whether it's water, whether it's weight, take your pick. There are lots of operations like, again, Yakima Power, who are trying to use these. In some cases, you know, as little as 300 feet can work for some of these big operations. Again, an old dumbwaiter or something along that line for low amounts of energy, depending on the weight you've got, might be viable. I haven't seen anybody doing something that small scale yet, but it seems like it's at least possible.
There's a lot on the internet about large buildings, skyscrapers being designed with them.
Yeah, and this is one of the companies doing that.
Cool.
Yeah, these are large scale. These are big operations and utilities and others. Some of the big computer systems, when you're looking at some kind of a large server farm, they're looking at this for AI as a large building next to it that can just store energy from wind, hydroelectric, take your pick. And this is just a diagram from one of them. So you got your rails, whoops. You got your rails, take your big weight, you just move it up, but then when you want it, you just let it slide back down the rails. Yeah.
Years ago, I remember seeing an ad, you know, 10 years ago, so like just using like a crane.
Yep.
And it would just pick up blocks and
Yep.
stack them and lower them. Is
Yep.
that a real thing?
That's a real thing. And again, somebody else Energy Vault gets involved in. Seriously, it's
That's a real.
these are real things. These are very efficient. They're just gigantic and they're huge construction projects. So can we make it smaller and make it viable?
Seattle used to have a ton of cranes downtown. What are those for?
We used to be second on the continent.
Ah, right.
Not this, yeah,
Bring them to your house.
not what they're designed for. All right, so phase exchange materials, mentioned those before, just a couple companies do this, but it sounds like you've got some comfort with it. I found it intriguing that if you don't live in the US, you might be able to get now comfort board, which has micronal inside. You're probably familiar with now for insulation, right? They sell this in Australia, and it has micronal that'll liquefy inside and then solidify again. It's just a nice little phase change material. Can't buy it here. Thermocool is ceiling tiles. They're available all throughout Europe with the phase change materials built into them. And phase change solutions, that I can buy here. They're little bags I throw on top of the drop ceiling. It's actually a pretty nice little feature. Microwind is one of the others that I mentioned earlier. It's a little outside of the booth here, but it's a single axis. There are a bunch of different wind turbines available from Microwind. And the nice part about having one single axis is there's not as much to break. And the way these are designed, I probably should put a picture up, but it's just a spinning item. There's not a big problem for
It's a
birds.
tube, right?
It's a tube, yeah.
Those are hitting the market really heavy.
And
I know.
the nice
Put
part,
them up anywhere.
yeah, flat roof. Do you have a flat roof?
Or put them in your yard, you can, I mean, at the
Yeah.
time.
I've seen a few in West Seattle.
Yeah.
The nice thing is the wind blows in the wintertime too. It blows in the dark, you know, you've got, the hard part is trying to get, you know, how do we estimate how much return we're going to get in the investment? Which is a challenge in a lot of areas.
They talked about replacing all the gyro, you know, all those, with those in the near future.
Yeah,
Cause they, you know, there's nowhere to put those, you know, blades at all. They gotta bury it.
so there are a couple companies, Veolia and several others, who are looking at recycling those. So a lot of the big name players in recycling are looking at recycling turbines in, you know, people are using them in the Netherlands. They're using them as shelters at bus stops and things like that. So folks are looking at the waste stream. For batteries, you've got companies like Kaspersky that are recycling lithium ion batteries without any troubles at all. As long as they get to them before they burst into flame, they're great. They can recycle them completely. Yeah, so
Isn't that a Russian company, by the way?
Kaspersky,
Yeah.
Yeah,
they're out of Southern California.
I think I heard your.
No,
Really?
Yeah.
They're American.
I thought they were a family in California that just has a fairly large recycling
Well,
operation.
there's a software.
Oh, that's different company.
Yeah.
Kaspersky Brothers is a recycling firm in California that's completely unrelated to the Kaspersky antivirus software. Sorry. Yeah, that is Russian.
I had to check.
That is Russian. Yes, no, they're Kaspersky Brothers is down in Southern California. They got one of the biggest recycling plants for batteries in the world.
So you're saying these flower turbines are actually here in Seattle?
There's one in West Seattle. It's a fairly large one.
On the ferry, right?
I was thinking of one up in Admiral District, west of California. Yeah, it's actually just sitting on the ground. It's a good sized one, not one with the little flowers.
Cool.
Yeah,
We have one out Lake Spanish too, Spanish.
they're being used on tours. Some of the bands will actually take them and actually set them up to try to power their operations. They're portable enough, they can do that. So they're pretty impressive. This is just one again of many of the micro wind generators that's out there. I looked at this one for just our own building. I live in a condo complex and our roof we're on the top of a hill.
Yeah.
And I figured, hey, to plug into the grid, we're looking at about $50,000. Which for a unit of 20 owners is
Not terrible.
not terrible.
12 and a half.
A lot of fixed income folks, so,
But you don't know what to beat that.
and we don't know what the benefit is to getting it. I know it's a good thing, but is it good for the people who are going to be there for how much of the rest of their lives?
See, like supply wind testers that you can leave up there for 6 months and see what you got.
Yeah, that's a possibility. So this was a little off topic, but I heard some interest, so I figured I'd mention them. We like these for this area just because it's so dark in the wintertime and our demand for power. Still here in Seattle, our biggest demand for power is in the winter for electric heating. PG&E could have said that PGE down in Portland could have said that 20 years ago, but their demand for power flipped. It gets so hot in Portland now that their demand for cooling in the summertime has now outstripped their demand for heating in the wintertime. So if you don't believe in global warming, and I'd be shocked if anybody here said that, talk to PGE about climate change because they have lived it. They have seen the demand for power switch completely. So that's it for me.
So with all, there's gonna be a shortage of water. It's just gonna be that way.
Yeah.
So how far out are we on a lot of these, scaling back down? Neighborhood association kind of things doing that. I mean, it's. That's why I'm a little worried about, we're getting rid of gas and putting all electric in, and then pretty soon we'll have no water. And then what are we gonna do? We're gonna freeze.
I'm not sure where to go with that question. Water supply is certainly a problem. We're finding more contamination with water supply. We are finding PFAS in the rain that's raining down on us. We are finding uncontaminated groundwater to be a very golden type of material. So, I don't know, desalination plants are probably going to be needed for a lot of different.
Well, in the same
Well,
line.
that's where I found out about that. That's a trouble, that too, the
It's
crack.
expensive.
What you do with all the extra salt, you throw it in the sea, it kills the water, you throw it on land, nothing will grow.
Yeah.
So.
You make it into batteries.
The salt.
Those are salt
That's the
batteries.
answer you can make, yeah,
Those,
maybe that's it.
they need to be refined, yeah.
$1 million idea.
That's,
So I saw, you all know who Bill McKibben is?
Yeah.
I saw him speak a few weeks ago when he was in Seattle. And he had this amazing presentation. He said he was done with writing books until he noticed a couple years ago that the cost of solar panels has plummeted over the last few years, much faster than anyone had anticipated, like to the extent that they're all coming out of China. And he said that China is probably going to become the first electro state, as in Saudi Arabia being a perpetual state. And so power generation from solar is way cheaper than any other alternative right now. And of course, if you look at Western Washington, we have nothing but land. So I thought that was a really bright spot.
well, yeah, and so Washington's gonna start buying from Oregon, a new solar farm that's gonna be out in eastern Oregon. Why can't we have that here in Washington?
Because the land's cheaper.
Everyone live in Oregon.
So on a large scale, the tilt of the sun, or excuse me, tilt of the earth towards the sun is really problematic for us in the wintertime. Because any energy that's coming to us is coming through more atmosphere, so we're losing energy in that fashion. The amount of time we actually get sun is a lot shorter in the wintertime. The amount of energy you can generate from a large plant is much lower in the wintertime. So we're not really looking to massive solar systems this far north. And the same thing with Alaska. Other power systems are much more efficient for us, dollar for dollar. Down in California, different animal completely.
Right. So they're more, this is probably southern Oregon I'm thinking of, but
Eastern
that
Oregon,
plate's gonna go online not too far from now, right? Or
Yeah.
already has.
yep, out towards, just east of Bend, towards Madras, that area, there are 2 big solar plants that are going online.
Would we actually need this if we didn't have any big data centers?
We don't know how much we're gonna need with the data centers. We thought we had plenty of electricity until people started planning what they wanted for power for data centers, and we flipped the script completely, as did every other power company.
What about offshore wind? You see, like looking into that.
Offshore wind is incredibly expensive. Trying to generate or trying to anchor them, avoiding damage to the subsurface, because these are active ecosystems. It's limited. It will probably form its own ecosystem eventually, but getting the power from offshore onshore is incredibly expensive to do. So per kilowatt hour is the most expensive form of power, followed by nuclear.
Okay,
How's that done now?
Sorry?
How's it done now? We have a lot of offshore wind.
Yeah,
They're
underwater
running
electric cables.
cables, is that what it's doing?
underwater electric cables.
Okay.
Yeah, we're looking at doing that. We're looking at that for an electric dredge for the Duwamish cleanup. To try to avoid having a diesel generator out there with a clamshell digging out the contaminants. We looked at having a plug-in system, building a substation and having an underwater cable, electric cable to run the dredge.
So,
So you don't have an answer right now. You're just talking
No.
about it. I was hoping for an answer.
To which question? I mean,
Well, which direction are you guys gonna go? What is our solution?
To generate more power,
Yeah.
we're trying to figure that out. Batteries are not a source of power. Batteries are a way to capture power that's being wasted. And then use that power. It is not a source of power.
Yes, but if we have demand more solar, because solar panels are so dang cheap, we just need to figure out a way to store that energy.
Yeah, and at this latitude, it's a,
You're saying it's,
I love the concept of using any type of a surface that's already impervious for solar panels. If I'm putting these on top of the house, if I'm putting these on top of a business, I support that wholeheartedly. But to go into large areas that are natural and just put giant solar farms in, I have serious issues with a lot of that. Damage we're doing to the ecosystems is pretty significant. And, you know, you get a big windstorm, you get a big snowstorm, you can do serious damage to the equipment. And it can be expensive to repair. It's really difficult to recycle these materials. There are PFAS and other hazardous chemicals involved in most of the manufacturing. Some of the solar panels still use selenium telluride. There are some toxic chemicals depending on who's manufacturing and what type of system you're looking at. Okay, so
Well, PFAS is, out of the system here in 2026 in the state of Washington, so. I mean,
we set up a law to require recycling for solar panels. If you wanted to sell in the state, you had to join in on this one, and companies decided to not sell here rather than come up with an end of life disposal. So we put that law on hold because, yeah. So we're not big enough to make that impact. California is, we're not.
Steve,
So, there are solar panel recycling plants, that we use, but just like big picture, 'cause I didn't really go into solar directly. It was more in relation to battery.
go ahead.
actually, yeah, we're thinking about that, speak to you.
Question and answer.
Just for like big picture. We're talking about two different solar things, one being commercial and large scale, and one being residential, and those are two different animals.
Yep.
Like commercial, like IKEA, makes a lot of sense, right? It's a used space. But just for your house. Larry was talking about like, low production in the winter, which is true. You saw my graph. But we have net metering in Washington, so what we do is we produce more in the summer, get credit for that to use in the winter. So as a resident, you're able to still utilize the energy from the summer during the winter in the form of credits. So it's not where you're generating for the grid, which is a totally different animal trying to subsidize the grid use when our energy use is higher. So residential solar production is quite a bit different when we're talking about net metering. Because you're looking at the net for the whole year. How much are you using for the year and how much are you
Yeah,
producing?
you're using the grid as a giant battery in a sense.
Yeah, and it's helpful to us too, because if we have a storage reservoir, and there are storage reservoirs along the Columbia and along our system too. If we've got a lot of solar in the summertime, we don't release that water. It stays there for recreation, it stays behind the dam, and when you need it, you turn the valve and water comes through the turbines when you need it in the wintertime. So conserving that water in the summertime is incredibly helpful, and rooftop solar is one of the ways to do that. On a larger scale, when you're looking at building out 3 times as much capacity to get the power that you need when you have 1/3 of the energy coming in, you start talking about acres and acres of land on a large scale solar system, which is just hideous compared to putting it on a building that already exists, which is a great option.
See how, let's say like a cogeneration or anything, that is, I mean. Every little, I have a substation right by my house, right? If that produced heat for my house, same time that it's, producing power.
There's heat loss all along the system. So the reason we transmit at high voltage is you get less heat loss that way. So the higher the voltage, the less heat loss you get. We used to have a 4 kV system here in Seattle. We switched to a 26 kV distribution system. And that 26 kV system, we have fewer substations because of that. And we can transmit the power longer distances with less loss of energy through heat. So that's why we switched out from having dozens of 4 kV substations to about a dozen 26 kV substations. It means our distribution lines are 26 kV instead of 4 kV.
Which is a lot more,
A little more hazardous, yeah, but they're.
which then impacts the amount of trees that we can't plant, right? I mean,
What do you mean?
isn't that, well, CCL's going around chopping down all these trees that are near power lines. That happened to me, big old
Yeah,
gorgeous joy and fur, and the city lights said it was, too close to the. And
didn't cut down the whole tree, just
no, they
did a
cut down the
horrible.
whole tree. Well, this, in this house.
So my question is, okay, you talked about Powerwall 4 generation we're on now, or 3? Three. So what's gonna be Powerwall 3 and whatever the next generation of, what are the next ones coming out? Would it be sodium? Would it be a new version of something lithium ion? Would it be, you talked about one other one? Along here that had high promise, we have no idea.
That remains to be seen, yeah. Lithium ion, when we look at like the battery backup systems for the waterfront, there were lots of options for ion batteries. There were several options for vanadium flow battery, because they were the second ones on the market. The ones that we looked at that looked more impressive to us, there was typically one big player and a few startups that were hoping that they might get somebody to buy their product and have a chance to actually grow. So it depends on, which of those actually gets to market.
It sounds like you and City Light and you and A&R have your own people who are doing the R&D and looking at research. Would it make sense that there be some collaboration between you, the R&D research department?
Sure.
And Future Sound Energy and whoever else is doing it, Future Sound Solar.
So there are two large groups in the electric industry. You've got the Edison Institute, which is for private power, and the American Public Power Association. And we work with, we try to work with NREL, the National Renewable Energy Labs in Golden. I don't think anybody there is working currently. I don't know how many are left.
God.
Yeah. But we work together as groups and have research bodies at universities that do research for, City Light's part of APPA, and Fusion Sound Energy is part of the Edison Institute. And we all have our emergency response groups that are associated with that. I go out on like your transformer that was down one of your pictures, those types of things I respond to.
Yeah.
Yeah. So, and if somebody needs help and they call, we send people to the associated groups. And that's how you fund the research, is through not just City Light, but we work with.
Spread it out throughout.
Yeah. So Austin Energy and, Snow Pud and Tacoma Power, we all pull some money into this group and they start funding research.
More questions for these folks?
I got a hypothetical since I have some expertise here. So if I was to start an off-grid campground and I wanted everything to be an all-electric campground, induction stoves, bigger washer dryer, run a well perhaps, right, for water. What kind of battery system and the kind of
It used to
idea?
be somewhere down by Josh's treatment
It would be,
in California.
Yeah.
Right.
and there's some there, let's say. And what would be your strategy, and you're assuming that campers are gonna come with, electric vehicles. What would be your, in terms of cost and safety and people not stealing stuff and running off with a bunch of things, like, how would you solve that problem?
It's probably in between us.
Yeah, I think the base is solar down there. The battery for off-grid, Tesla's out, they only do grid tied. Not sure if Franklin does off-grid, but off-grid, solar and battery is I literally don't design that, I only do residential grid tied. So doing off-grid it's a whole nother expertise, a whole nother level of design, because you can't use, as we were saying earlier, the grid as a battery to dump excess energy. It all needs to be maintained on site. So if you have, you might only be able to have 5 solar panels, or you're gonna need a large battery bank to handle all the power, but it's not being used.
Well, that's one of the things that I contemplated. Solar panels might have a proclivity of disappearing in the desert. But like a big heavy battery, locked in a storage, they might actually be less.
Thanks, that 9,000-pound thing.
Yeah,
Cause like,
got space.
especially on a campsite, it's not necessarily used all the time, so you might have a trickle charge of a couple solar panels powering a relatively big battery to store it.
I was thinking the same.
Okay,
Right. You got the space for it, a sand battery, if you get excess charge, it can absorb a huge amount of energy. They're ridiculous, though they tend to be very.
Can I say something?
Hold on,
On
Catherine,
your-
we're in the
Out
middle,
there?
they're in the middle of describing something.
No, you need that, where's the energy gonna go? You have 10 kilowatts of solar.
Your
coming in.
battery.
Well,
Yeah,
yeah,
you need a battery, but
it's
you,
physically disconnected. If I took physically went on my roof and physically disconnected my panel from my roof. it would-
you could do that. You wanna do that every time? Every day?
Well, There's gotta be an electric switch or something.
There's automatic shut off switches when the grid is down for solar systems.
Yeah.
Grid tied.
And a lot of that's to protect our workers.
It is 100%.
And it's like your workers.
Yeah.
It's for line workers, not electric. use.
So there's no way to access the battery power when you're grid tied.
All
the
kinds of
grid's
people
down.
have off-grid batteries. It's good.
Yeah, but you need big battery systems
Yeah.
to handle, well, it has to size up. So if you have like a 10, like I could have a 10
So you have
kilowatt,
to make sure you use enough power every day so that you don't overload your batteries.
so you gotta think about total use, cause like I can,
So you just leave the light on.
so I have
15
12 kilowatts of solar generating.
Say-
And, yep,
You're saying you can't, you have produced solar, you have a battery. Your battery says it's full. You can't just have a physical disconnect switch that just switches it, says battery's off. It's not charging until the battery.
so I will go back to, I don't do off-grid design, so I
Yeah,
don't know
yeah.
the details. I just know that the amount of batteries you need for a 10 kilowatt solar system is exponentially bigger than how many you need when you're grid tied.
When you see the lithium ion battery failures, you can find these online without any trouble. When you see batteries from these portable devices that blow up, one of the failure modes is overcharging the battery. And you get too much energy in, you can do physical damage to the lithium ion battery, and it responds by exploding. The electrolyte's flammable. So you have all of a sudden a high energy, a fault, and a flammable liquid, which very quickly becomes an engulfing fire in a room. So that's the type of failure mode we're talking about if you're getting too much energy to your system. And a battery management system is one of the key items in there
Yeah.
to try to keep that from happening. But you can still get too much power, even if it's the manufacturer's design and they're shunted in properly.
Yeah, I mean, it sounds like basically there's a failure mechanism fails. Blow up your house.
Yeah, and it's usually a problem where somebody gets a third-party charger for their e-bike and it overcharges the battery, or it bends the battery too much, and then it blows up. So it's got a failure mode on both ends, unfortunately, with a lot of lithium-ion designs. LFP has been much safer, but
I was gonna say that.
yeah, no,
LF.
lithium iron phosphate, yeah, that is much safer. Lithium titanate interesting, like really interesting, but fairly new chemistry on it. Well, it's been used in space for a while, but.
Just to give
Can
you-
I? Something?
We got about 5 minutes of group discussion left, final closing things.
I think.
Oh, you got it's because you're here on.
Interfering.
You're here twice.
I blew it.
You can just leave on, you're here twice on 2 different accounts. On that computer, so just leave on one of them. And you'll fix that,
At least mute.
or at least mute one of them. Okay. Now try unmuting one. You're still muted. And if we can keep this to a brief.
Okay, I'm there. Okay, so listen, friends moved to Michigan and installed solar electric cells as they did in Oregon, using the panels that produce power from both sides. They were feeding energy back to the grid in 26-degree Fahrenheit weather last winter, having more than they needed for their house. And I want to say conservation is still our major new energy source. And I also want to say, I have a question about phase change salts, otherwise known as Glaubers or eutectic. Have they improved in the last 50 years? Engineer Maria Telkes had designed a phase change solar heated house near Boston that received American Solar Energy Society award. But the phase change salts 50 years ago were only lasting for 200 phase changes and needed replaced. And finally, the 80,000 utility-sized batteries that exploded in Moss Landing, a county commissioner there called it a technology out of control. It contaminated the soil. Of 70% of the vegetables in the country are grown there. It's America's salad bowl. I think we need to rethink our whole electricity use and not plunge forward with the lithium-ion batteries just so we can have more data. That's my opinion. Thank you.
Thank you, Gary.
Yeah, we're kind of in the same boat as City Light. We were really looking at other alternative chemistries. And part of that was the inherent hazards in the design of every lithium ion battery we're looking at.
Right.
So that's why we looked at the other chemistries and we found them to be preferable, but not for every usage yet. So we did install one at Miller because it was the only one that would actually function for us in application.
Do I understand correctly why lithium ion is used in cars such as this is the life weight technology so far?
It's the energy density. So it's the amount of energy you can get per kilogram of material. And these batteries are ridiculously heavy. We're looking at electrifying our fleet. And when you start looking at a battery electric vehicle, and we have some in our system, most of our cars are electric batteries. But if you're looking at a fire truck, it's at a weight limit for the road already, or our electric bucket trucks are at a weight limit. So what do you remove from the vehicle to add the extra weight for the batteries? You remove the ladder from the fucking ladder. That kind of removes the purpose of the truck. So do you send a second truck with it? If you have to remove certain weight to account for the batteries in that heavy vehicle, you send a second truck with it that's also battery powered to carry all the rest of the stuff that you couldn't carry in the first truck. These are the type, and where do you park those second vehicles?
He was asking about what's the advantage of lithium ion?
It's the energy per mass.
Yeah.
Yep. Yes, the energy density.
So you don't need it, you can have something super heavy sitting, that's where.
Well, right, yeah.
That's where the metal oxides are interesting.
Lithium ion is the lightest option so far.
Except for the metal oxide, some of those are really pretty impressive. And sodium is not as energy dense. It's pretty impressive for most usage, but when you start looking at cars, you're not gonna get the range out of that car.
Are we talking about like 5% more impressive or like 30% more impressive? Just curious, I know nothing about the.
There are enough sodium chemistries, and I'm not sure in CATL, I think they were looking at about 70%, 80%, somewhere in that range, so pretty good. But it varies by which one you're looking at. We're replacing lead acid batteries, and for that, it's a no-brainer. They're smaller, they're lighter weight, and they're just as effective, and they last just as long. And they don't have lead or sulfuric acid. So, yeah.
I think it might be time to wrap this session up, folks, and one more round of thanks for Solar Chief. Possibility of going to the pub,
Yeah.
and the conversation, that's always a possibility with this crowd.
We have our own room.
And then Rebel Rebecca, she has a top secret thing that she wants to let us in on the secret about.
So I'm gonna tell you this, but don't tell anybody. We are gonna have a movie screening that we are going to co-host with Passive House Northwest. It's gonna be at the Beacon Theater on Rainier, in the Beacon Hill area, on February 12th, 7 o'clock. So stay tuned. There will be more details up on our website as we figure them out.
And the film is called,
The film is called Women, thank you, Women of Carbon.
and it's really good.
It's really good. John has seen it.
I have not.
Oh, okay. Well, I've seen the trailer and it looks really good. And it also features several Northwestern women who are leading the carbon reduction movement in various forms. We're gonna have a panel, all TBD. If anybody wants to get involved and helps organize it, we'd love that. But it's gonna be really exciting. And then we're also gonna have a holiday party